All right, so we're going to have a pretty easy and nice discussion today about securing cloud environments. And no, the cloud is not secured by default. You might think that whenever you're buying something from a cloud environment, that security is also part of the package, that you are also paying for somebody else to manage your security. Well, it might be so, but it's most definitely not always true. So let's see what this is all about. So first, let's review the available cloud deployment models. So how do you actually purchase something in a cloud, or what type of clouds are there? Starting with the public cloud, because this is the one that pretty much everybody thinks about whenever they hear the word cloud. This is the realm of Azure, AWS, Google Cloud, Oracle Cloud Infrastructure, and so on. We have major and minor cloud vendors out there which pool their infrastructure, share their infrastructure among multiple customers. And you can simply purchase the infrastructure and the services within these cloud environments. You just pay for as much as you use out of that infrastructure, and you don't have to invest in any kind of on-premises equipment. You can actually run an entire business solely on the cloud. Now, in order to be able to offer this, of course, major cloud vendors have huge data centers spread all over the world, in regions, in all continents out there. So you're going to have to choose in which region you're going to host your data, and you're going to have to think about data locality, as in where are your customers actually located, and how can you deliver the services that you're planning on hosting there as fast as possible, depending on their location. As expected, all the resources that you can buy in a public cloud are all virtual. Now, there are some exceptions, and major cloud vendors have started providing you the ability to rent actual physical hardware for some specific corner cases and use cases, but 99% of the time, what you're going to be buying in a cloud environment is going to be a virtual service, going to be a virtual machine, a virtual network, a virtual IP address, a virtual something, because the principal tenets of the cloud are elasticity and self-service, and you simply cannot reconfigure hardware the same way you can reconfigure software. So if you plan on being able to flexibly offer a plethora of services and of resource types to your customers, then you'll have to make sure that you have some sort of automation behind those, which enables you to provide those services and those resources as virtual resources. And depending on what exactly you are buying from that cloud vendor, security might be your responsibility or the cloud vendor's responsibility. We're going to talk about this in a future slide. But just to keep things short here, regardless of what type of service you're buying, whenever you start bringing in or creating additional data or bringing in your data to be used in that cloud environment, that data belongs to you. And the responsibility for securing that data is almost always going to belong to you. So you have to take care of securing data at rest whenever it's stored, and you have to make sure to secure that data when it is in transit. Now, cloud environments allow you to use their internal network, but can also allow you to use the public internet to communicate with your clients or between disparate services within the same cloud vendor. You get to choose which path you're going to use, but if you choose to use the public path over the internet, then the security of that data becomes your responsibility. Also, don't forget that the cloud environment often gives you all the available tools and functionality and the security features, but it's up to you to implement those and to configure them. So it's not enough just to have access to firewall abilities, to layer 7 inspection, perhaps in a cloud environment. You also have to enable it, and you have to monitor those in order to actually get some security benefits out of them. Two special categories here related to public clouds are community clouds, where multiple companies pool their resources and their costs for maintaining such a cloud infrastructure for a common reason, and multi-cloud, when a company simply uses services from multiple cloud vendors. By the way, if you see the acronym CSP, that is Cloud Service Provider, basically a cloud vendor. So it's going to be Amazon, Microsoft, Oracle, Google, one of those probably. We also have the term of private cloud, which you might have heard in the past, and it's nothing more than a completely automated and virtualized data center that you own. So it's under your domain, it's under your administration. Now, in order to be considered a cloud, even though the cloud is actually a marketing term, it's supposed to be completely automated and designed for self-service. So even though you are hosting your own infrastructure and the servers and the storage appliances and the networking appliances, they all belong to you, the interface for any of the services, the virtual machines that are being offered by that infrastructure is supposed to be designed in such a way so that your resources can easily scale up and down or scale horizontally. And also, it's supposed to have a friendly to use interface that allows the users of that cloud infrastructure to perform self-service operations. So in order to create a new virtual machine, you should have a portal here that says, I want to create a new virtual machine that anybody can use, not just the data center admin. Of course, the responsibility of everything falls onto your shoulders. From the hardware to the software, to the firmware, to the update, to the security, to the data and the applications that are running on top of that private infrastructure, it's all yours. And the reason for such a huge investment, and by the way, it is a huge initial investment to buy all that equipment, because most definitely you're not going to be using it at full capacity the entire time you will be exploiting that infrastructure. The reason for doing this is most likely going to be for reasons concerning privacy and a high degree of security. Now, this security, it's kind of like a two-edged sword, because on one hand, people tend to think that whatever belongs to them and is located under their roof is inherently more secure, and it's by default more secure, other than trusting somebody else or some other company with your data. Unfortunately, this is not always true, because most companies that start to build a private cloud don't exactly have the unlimited resources to invest in a security effort for protecting that infrastructure. Now, you probably are never going to be able to match the security team that is employed by Microsoft to secure their own public cloud, or a security team employed by Amazon for AWS. What you will probably do is hire a couple of people to take care of that security, but are you sure that those people are enough? And you sure that the skill sets that you're bringing into the company is enough to protect that data that you thought is going to be more secure under your roof rather than under a major cloud vendors? That's something to think about. Also, for regulatory purposes, you might have to store that data locally, so that perhaps if you will need to use a cloud infrastructure from a public cloud provider that is located outside of your country's borders, you might not be able to do that due to specific regulatory or legislation requirements that apply to you. So in that case, you might have to end up using some local provider or even your own data center to store that data. Finally, we have a combination of public and private, which we call it hybrid cloud. And the combination actually refers to the fact that whenever you start with a private cloud infrastructure, at some point you might need to scale out higher than the current capacity allows you to. Think about scenarios for, let's say, Black Friday in an online store. They might be running their servers on 2 or 3 servers, maybe a small server farm on premises. But when Black Friday comes in and they start seeing 1,000 times more users accessing that same web application, they're going to need more resources. What do? Do they buy more servers just for a couple of days? No, but they can rent additional capacity from a public cloud environment, thus connecting that additional capacity to their own premises servers and expanding that capacity into what is called now a hybrid cloud. Now, another implementation of a hybrid cloud might be, for example, a company that tends to prefer to store their data locally, but can also use additional services from other cloud vendors, such as they rely on external authentication services, or they might be willing to allow their users to store their data into something such as Dropbox or OneDrive, or allow them to use a cloud email solution. That's also one implementation of a hybrid cloud. Now, from a security perspective and from a management perspective, this is the toughest one to administer, because you actually have to administer 2 separate environments that become pretty hard to synchronize. I mean, if you have a security policy, it's going to be difficult to implement it exactly the same way using your own equipment and the public cloud vendors' services. Monitoring is also more difficult because you might not have the same visibility in a public cloud environment like you have on your on-premises infrastructure, where you can simply attach a Wireshark to a network cable and you're going to see everything that goes on in there. So the story of responsibility can actually be displayed in something like this. First of all, we're going to be focusing here on what exactly are you buying from a public cloud provider. So for example, if you are looking at infrastructure as a service, this is IaaS right here in the middle, it means that what you're buying from the cloud vendor is just pure infrastructure, virtual machines, servers, networking, security appliances, storage entities, and so on. Whatever happens on top of that, actually on top of the virtualization layer, that's your responsibility. So the cloud provider ensures that you have access to all this virtual stuff in here, networking, server storage, virtualization, and also make sure that the hypervisors are up to date and all the firmware is kept up to date and all the redundancies in place. But everything starting with the operating system, starting with the applications that are running on top of it and the data, that's going to be your responsibility. You're basically buying the equivalent of pure hardware, unconfigured hardware. Next deployment here is of type platform as a service. Now, platform as a service, PaaS, is sometimes misunderstood by people. That's because it allows you to bring your own application code. That is, it provides you with a platform for running your applications. You just have to bring in your applications and your data, and that's it. Which means that platform as a service is going to provide you with the hardware as well, even though you might not have direct access to this hardware anymore like you had with the IaaS. But what it does offer you is managed services for file storage, for databases, for running .NET or Java applications, or for running whatever application code you need to run. But the entire environment is now managed by the cloud provider. So the runtime, the middleware, the operating systems, these are now the cloud provider's concern. You are only concerned with bringing your application code, and of course any security flaws and security issues that you might have with your application code are still going to be your concern, and of course the data that your application is going to be using. Finally, the last type of implementation is software as a service. This is the simplest one actually, because you're buying everything as a prepackaged environment from a cloud provider. You're buying the application with everything that the application needs to run, down to the virtualized resources and the physical hardware. Now, you're not going to have access to all that low-level components, but you will have access to the application itself, the application's interface. So basically, this is what you're doing whenever you're buying something such as Exchange in the cloud, when you're buying an email service, when you're buying a SharePoint in the cloud, or Office 365 or Microsoft 365, any type of software that is ready to use the moment you press that buy or enable or launch button in a cloud environment. That's going to be a software as a service type of deployment. The only thing you need to bring in, because you already have a functioning application, is the data. So you have to configure that application, you have to import your existing data perhaps, or existing users. That's going to be your concern. Other than that, the well-being of the application, the monitoring of the application, the hardware on which the application is running, it's all going to be managed by the cloud provider. You're just paying for the application. In a cloud environment, you could also ask for security as a service, starting from simple access to experts and consultants, which are just providing advice. But this is not really exactly in any way connected to the cloud environment, right? But what we can actually implement through the cloud is by leveraging something called a managed security service provider. This is relevant in situations where you choose as a company to outsource the security responsibility and the security effort of implementing security to another company or to another service in some cloud out there. So that's the MSSP implementation. Going even further, with security as a service, this uses the cloud environment 100%, and this refers to situations where you choose to implement things such as firewalling, intrusion prevention, maybe antivirus scanning, maybe user authentication as a service that is completely hosted in a cloud environment. All of this cloud business and all of this cloud discussion can only happen as long as your infrastructure is completely virtualized. It might be private, public, whatever. It's always going to be about virtual resources. Now, just a quick recap here with virtualization and virtual machines. You probably know this, right? But in order to provide you the ability to run multiple virtual machines, multiple instances of an operating system on top of the same hardware, we basically need, of course, we need the hardware, we need the physical machine here at the bottom, but we need the component which is called a hypervisor. Now, the hypervisor is just a small footprint operating system that is designed to slice the resources made available by the physical machine and to allocate those resources to as many virtual machines as we need. Of course, those virtual machines are not going to be able to consume more resources than are physically available on the physical machine, but you can do some oversubscription in here, assuming that you will never encounter a situation where all the virtual machines are going to be burning at 100% at the same time. Now, on top of the hypervisor, since this is the resource that makes available these sliced resources, we can instantiate our virtual machines. Now, a virtual machine is nothing else than an isolated environment that runs a dedicated operating system. On top of that operating system, we have the necessary libraries or necessary utilities for a specific application to run in there. We usually prefer to have one application per virtual machine to avoid situations where different versions of libraries can clash with one another. One application requires one version, one application requires a different version. So we get into something called a dependency hell. So we prefer to keep everything neatly separated. Now, of course, these operating systems in here can be anything, right? You can have Linux, you can have Windows systems in here. And of course, these applications that are running on top of them have to match the operating system that they were designed for. Now, the abilities of the hypervisor nowadays are many, and they can range from simple scaling abilities, such as dynamically allocating more resources to a virtual machine even while the virtual machine is running, down to some advanced functionality such as direct hardware access to specific components, such as direct access to a high-speed network interface card, or direct access for a virtual machine to the GPU, a powerful graphics card that might be attached to that server. So that's virtualization for you. So for virtualization to happen, we need a host, that is the physical server, we need a hypervisor, and we need the virtual machines. There are actually two types of hypervisors. If you go back to the previous drawing right here, what you see here is actually a type 1 hypervisor because it's actually located right above the physical machine. So it's installed in a bare metal approach directly on the physical machine, and it becomes the only operating system that is running on top of that physical machine. We could also have another operating system right in between here, the hypervisor and the physical machine, which would make that hypervisor to be a type 2 hypervisor. A type 2 hypervisor runs not on top of the physical machine directly, but on top of an operating system that is running on top of the physical machine. Example of type 2 hypervisors are a VMware Workstation, Parallels on Mac OS, a VirtualBox, and Hyper-V in Windows. So any type of virtualization software that can be installed on top of an operating system. It's worth mentioning here, even though we did talk about this in a previous video, about VDI, Virtual Desktop Infrastructure. We said that this is a deployment where the user's desktops are actually implemented as virtual machines running in a centralized data center. And users only use a thin or a thick client or any type of device, basically, to connect over the network using a remote desktop protocol type of connection to that virtual machine in the data center. It's still about virtual machine, it's still about virtualization, it still brings the same benefits of scalability, of resource usage, of management to be able to quickly rebuild and repair virtual machines for your users, but it also might create a single point of failure due to the fact that all the virtual machines are running in one single place, and due to the fact that all the users need an active and pretty powerful connection to that data center in order to reach their desktops. And since we mentioned virtual machines, we should be mentioning containers here as well, because containers have nowadays become a very widespread technology. It's a pretty old technology, introduced many tens of years ago, but recently they have become so easy to adopt due to technologies such as Docker or Kubernetes, and so easy to manage that it becomes a no-brainer to at least give it a try when you're planning on building an infrastructure for your applications. So what exactly is a container? Now, if you're looking here on the Docker website, you're going to see a comparison here between containers and virtual machines. And on the right-hand side, you can see that's a picture that's quite similar to what we just saw on one of my previous slides, right? We have the infrastructure, we have the bare metal servers here at the bottom, we have the hypervisor right on top of it, and then we have virtual machines, which are running separate operating systems and separate applications. Now, on the left-hand side, we get to see containers. Notice that at the bottom, we still have physical servers, right? We're still using CPUs and memories and, and motherboards and disks and everything else, right? But on top of that, we are running now an operating system. It can be Linux, it can be Windows. Traditionally, it's going to be Linux because, Linux is the place where containers were actually born, so to say. And on top of it, we also have a container engine or some sort of an application that is container aware, that allows us to use the container functionality from within that host operating system. Notice that on top of this container engine, which in this case could be Docker, could be anything else, we have our containers. But those containers are missing something. They're missing an operating system. And that's basically the main difference between a container and a virtual machine. The container never encapsulates the operating system, but only the application. So the container becomes a wrapper, an isolated environment for running a specific application. But if it doesn't have an operating system, how does that application actually run? Well, it actually runs using the kernel from the host operating system. So we have one operating system running on our server, and then we have as many containers as we need, all of them containing one single app, and all of them using the same kernel from the host operating system. So you have one single operating system, many containers, all using the same OS. This creates some advantages and disadvantages. First of all, one advantage to this is that containers are blazingly fast. It only takes a couple of milliseconds to instantiate this isolated environment here, and then it only takes as long as it needs the application to boot up, and that's it. You don't have to wait for the entire operating system to boot up. Consider how much you have to wait for a virtual machine to start. That's a good side. That's the best side of containers. The downside of containers is that, well, since we only have one single operating system, it means that all the applications that are running inside of these containers have to match that operating system, have to be able to run on top of that operating system. So we're not going to be able to mix and match Windows and Linux applications on the same host. We could have a host dedicated for Windows containers running a Windows kernel here, or we could have a host dedicated to Linux containers that is running a Linux kernel here. But we have to run containers specific to that operating system, because otherwise they're not going to be able to talk the same language. So that's the shortest story ever about containers and virtual machines. Hope I managed to shed some light into this area. Finally, talk about security risks and virtualization. Now, these are more like theoretical security risks, because if we had a situation where these security risks were actually exploitable now, currently, then we would probably see all the cloud businesses failing all over the world, and all the private data centers would become isolated from the internet in order to protect them. So these risks, especially VM escape, this is a potential security risk in which if the hypervisor is compromised, then potentially a virtual machine on the same hypervisor could be accessing the data and the resources from another virtual machine on the same hypervisor. You might think that this is not exactly the greatest danger out there. It is. It is pivoting, it is lateral movement, it is privilege escalation if it happens in your own data center. But think about this happening in a public cloud environment where you are sharing the same high-powered server with 100 other customers. That would be disastrous, right? So that's VM escape. Another obvious risk is VM sprawl. VM sprawl is nothing more than a bad practice on behalf of the admins or the users of that cloud infrastructure. The thing is, whenever it becomes so easy to create virtual machines and resources, people tend to forget about them. People tend to forget to clean up after them. I've just created a virtual machine, I've just tested something, then I forgot about it, and 6 months in the future, somebody comes in and asks, what the heck is this virtual machine doing in here? Nobody has connected to it in 6 months, it's still up and running. What does it do? And nobody knows what it does because the person who created that virtual machine no longer works there. And nobody wants to touch that virtual machine. Oh my God, I'm not going to touch it. What if I break something? I don't know what's with that. I'm going to just leave it running in there. And that's VM sprawl. Over time, we're going to keep having situations such as these where resources are created and then abandoned simply because it only takes you a couple of seconds to create that virtual machine or that container. Downside of this is, of course, you're going to waste some resources. But the real downside is that you're going to have a piece of shadow IT in there, a lot of virtual machines with a lot of testing software on them that exposes you to additional risks because nobody manages them anymore. Nobody even has login credentials to them. So nobody updates the software on them or includes them in security assessments or automated patching processes. So that's VM sprawl, right? The uncontrolled widespread of virtual resources. Well, cloud security auditing is the topic of a completely separate certification there. And it's actually going to be a lot to talk about here. We're going to try to keep it simple, but keep in mind that whenever you're talking about cloud infrastructure, it's even more complicated than when you're talking about your on-premises infrastructure. Because when you go in the cloud environment, there's just so much more that opens up to you. So many types of services, so many types of interconnected entities and APIs and permissions and applications that are running distributed all over the place. Applications that are managed by the cloud provider, that are managed by you, and so on. So whenever you plan on not just managing this infrastructure, but on performing a security assessment on this infrastructure, be prepared. It's going to be a lot of work. So with cloud security auditing, what exactly should you be on the lookout for? First of all, since the cloud is an isolated environment in itself, you're going to have some keys to the kingdom. Those are going to be some API keys, going to be some login credentials, which don't apply to your on-premises infrastructure. Right? With on-premises, you will need to gain access or physical access to the building or to the network, but with the cloud environment, everybody has access to the login portal of AWS. You just need the right credentials or the right keys to interact with the API. And there you go. You might actually lose access, you might compromise your entire infrastructure due to a single compromised API key. So access management, one of the first things to review. Secrets management is also connected to access management because, as I said before, those keys can actually enable access to the entire kingdom. So whenever we talk about secrets, we're talking about API keys, we're talking about a method for securely storing and distributing those keys so that they don't end up in your software, hard-coded perhaps in some application code that is being pushed to GitHub and becomes public knowledge. So be careful about this. Then, of course, we'll have to focus on securing the actual instances that are running in that cloud. No, we don't have physical servers anymore, but we have virtual machines and we have containers. And unfortunately, the way you implement security for a virtual machine and for a container is so different. And perhaps because, by definition, a virtual machine is more of an isolated environment than a container, people have grown used to the idea that containers are less secure than virtual machines. And yes, out of the box, they are less secure. But they do offer a lot of security features. You don't have to know about them, you have to implement those and test those, right? Security is never out there by default, ever. You do have to implement it, you have to take care of it, you have to update it and keep it up to date. The same goes with virtual machines, and the same goes with containers. And don't forget that at the end of the day, those compute instances, those virtual machines and those containers are still running normal applications, which are going to have the exact same vulnerabilities regardless if they're running on a virtual machine or if they're running in a container or if they're running on a Raspberry Pi on your desktop. API security. Again, don't forget about the API because cloud environments, all of them, all public cloud environments expose APIs because they're designed to be interacted with in an automated manner. Using tools such as Ansible or Terraform or even basic scripts written in Bash or Python, you are able to interact with the API to automatically provision and manage and deprovision your infrastructure. So the credentials that you're using to interact with that API need to be thoroughly secure. Don't forget about cloud storage security. I'm talking here about object storage specifically and the buckets that you can create in those object storage services. All major cloud vendors out there allow you to create object storage entities and to make them publicly available. Some websites and some well-known websites actually like Netflix or Dropbox or even Spotify, they all use the infrastructure, the object storage infrastructure from major vendors such as AWS, using the service called S3, that's object storage in AWS. Now, the idea here is that cloud storage is there to store your files, but the permissions and the policies for accessing the content that is stored in there, that's your responsibility. Sometimes people forget that the default configuration for these storage entities is to be public, and they end up wondering why they had a data breach. Well, simply because somebody forgot to make that bucket private. So it's not the cloud's fault, it's your fault for not making sure that the access policy doesn't allow access for anyone from the outside. Actually, a lot of the data breaches out there, especially in the recent years, were due to misconfigured policies on either GitHub or on object storage. Somebody forgot a few permissions in there, which allowed a hacker, quote unquote hacker, because you don't even have to be a hacker to access a publicly available resource and download the files in there. You also have to manage availability risks. So it's not just about confidentiality and integrity. Availability means that whenever you have resources deployed in the cloud, well, those resources live in some physical data center somewhere. You might want to make sure that if something happens with that data center, even if it's not yours, if something happens to it, you're not losing your entire business. So you might want to think about replicating those resources, creating duplicates, creating high availability pairs, creating clusters of resources spread over multiple data centers, over multiple regions, even among multiple continents, perhaps, especially if you have a global audience. So all the cloud providers have the ability to provide you with resource replication, data replication, regions in which to deploy that data or those resources, availability zones to avoid situations where, natural disasters perhaps or major faults can affect an entire data center. That infrastructure is there for you to use. Of course, it has a cost. Now, if you're going to be running the same application on 2 different virtual machines in 2 different regions, you're probably going to be incurring double the costs. But you will have redundant infrastructure. Also, don't forget about cloud networking. When everything was on premises, you only had one single network, and you knew that everything had to live inside of that network. You had to go outside, you would have a single point of exit. Now, with the cloud, it's not exactly so easy anymore. With the cloud, you can use the internal cloud's network to communicate among different services, perhaps in the same cloud vendor, but you can also use the internet to communicate between them. Also, don't forget that your users are going to be connecting over the internet to any services that you're making available in your cloud environment. And those users might be connecting from Europe, from the US, from Asia, from Australia, from wherever they might be coming from. And it's not going to be just a single connection point. It's not going to be just a single point where you have to implement a security policy. It's going to have to be a global policy. Right? Also take care of segmenting resources. Make sure that you're not exposing resources that run the risk of being compromised and that you're not facilitating a pivoting operation to a potential attacker. So yeah, you are going to have to expose some web servers perhaps, but don't expose your databases. Don't expose your middleware. Don't expose whatever third-party internal services you might be using in order to make that application work. Cloud providers allow you to define public and private infrastructure. So you can have private subnets, which are only running internal services that are completely unreachable from the outside, or you can have public subnets where you can host things that normally would be placed in a DMZ in a traditional environment. VPCs, virtual private clouds, or VNets, or VCNs, virtual cloud networks, or depending on the cloud vendor's terminology, are basically virtual networks. And the virtual networks in a cloud environment have become slowly over time a method for segmenting resources, simply because most of the resources that you're creating in a cloud need to be attached to a network. So the moment you start creating separate networks and attaching resources to them, you're basically segmenting entire domains between the services and the applications that are connected to those networks. So VPCs, you're going to find VPCs in AWS, you're going to find VNets in Azure, you're going to find VCNs in Oracle Cloud. These are disparate and completely independent virtual networks. They're implemented as overlay networks, and of course they can be regarded as traditional networks in a traditional environment, on-premises environment. You can create subnets in there, you can attach routers to it, you can attach internet gateways, you can attach NAT gateways to them, you can do whatever you want. A transit gateway can be a number of things. It can be a smart router that can interconnect multiple VPCs. It can be a router that can enable you to communicate with the outside world. It can be even a router that can establish an always-on IPsec tunnel with your on-premises infrastructure, thus enabling you to deploy what is called a hybrid cloud. Finally, the VPC endpoint, and by the way, I do have some problem with this terminology here because even though CompTIA brags about being completely vendor agnostic, well, what they're saying here and what they're focusing on is strictly AWS related. So the terminology is strictly AWS related. We're gonna have to live with this and keep calling it a VPC endpoint, even if it's a strict AWS term. Now, VPC endpoint is an entity that can be configured in AWS that allows your resources to communicate with other services, perhaps storage services, perhaps APIs, perhaps authentication services, using the internal network of AWS in order to avoid going through the public internet. So that's a VPC endpoint. Finally, last but not least of the security functionality available in a cloud that which should be part of a security assessment is the firewalling functionality. That is deciding which traffic should go in and out of that cloud environment or in and out of a certain virtual machine or container. Now, cloud firewalls are sharing a lot of functionality with the traditional firewalls that we've gotten used to from the physical world. So we can have firewalls that look at the network layer, layer 3, you're going to have firewalls that look at layer 4, you're going to look at port numbers, and we even have application layer firewalls which can inspect traffic at layer 7 and can also provide some intrusion prevention functionality as well. Now, regardless of their actual complexity or layer at which they're working on, we do have several deployment models in which we can implement them. First of all the cloud vendors out there have some sort of a native firewall implementation. It could be called a security group, it could be called a security list, it could be called an access list. There is some sort of a built-in firewalling functionality that can be attached to virtual networks, to subnets, even to specific instances that behaves just like a hugely distributed firewall that can touch each and every instance in your cloud environment. And that is native functionality. Now, it's not going to provide you with the same benefits as your Cisco firewall or your Fortinet or Checkpoint firewall. That's why cloud vendors also provide you with the ability of instantiating a firewall appliance, a dedicated virtual appliance in their own environment. Most cloud vendors out there have some sort of a marketplace where you can simply buy additional infrastructure that is licensed by other vendors. So if you have gotten used to having Cisco Firepower firewalls in your environment and you're moving to the cloud, you might want to go ahead to the marketplace. It doesn't matter which cloud it is, they all offer pretty much the same vendors out there, and just buy a virtual Cisco firewall. You can just buy it, it's going to be deployed automatically as a virtual machine. You're going to be paying for it, of course, you're going to be paying it as a subscription this time. You don't have to buy any hardware for it, but you can choose where to deploy it, in which network, how many interfaces it's supposed to have, how to connect it to multiple subnets, and then you can just log into that traditional web interface that you've gotten used to and start configuring your Cisco firewall just like you did in the old on-premises days. So we do have the opportunity to run these specific third-party vendor solutions for dedicated firewalls, even in cloud environments. Or at the end of the day, of course, you could just manage your own virtual instances and connect to your Linux and Windows instances and simply install your desired firewall software on them. Right? You could have a simple instance that acts as a bastion host where you just SSH into that instance, you just install IP tables on it, you configure IP tables, and there you go. That's your firewall for your entire rest of the cloud infrastructure. Good luck configuring it and hardening it, because that's going to be the last line of defense for your entire cloud infrastructure. You have been warned. And finally, the last solution here that I'm going to be talking about, and I promise this is where the video is going to end. It's called CASB. I like this name. Cloud Access Security Broker. Now, the CASB is just a component that can be deployed, software component, can be deployed on premises, or it can be deployed as part of the cloud environment. Its purpose is to act as a proxy for any interaction that is coming from on premises and is reaching out to one of the resources in the cloud. So it kind of acts like a firewall, but for cloud requests. It's able to analyze API requests, it's able to check the user identity of whoever is trying to manage a piece of infrastructure in the cloud. It's able to understand all the requests that are coming in to interact, for example, with file storage entities. So it's able to detect whether a specific user has or shouldn't have access to a specific file in some cloud, remote cloud storage device. So it can actually act in a very, very granular manner. Just like the name says, it's a security broker. So it's some sort of a firewall or a proxy that analyzes all the requests coming in from outside or from on-premises that are trying to reach resources in the cloud and decides whether those requests are allowed or not. Alright, I told you this is not going to be a difficult subject, and I hope I managed to keep my promise. So thank you so much for watching. Share this video, like and subscribe, support the channel if you wish, and don't forget we still have more to go. So see you on the next video. Good luck and bye bye.